Do you all know what is broadcasting? Wait, someone has joined. Viewer. Do you know what is broadcasting? I'm not talking about the. No, 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 not this method. I'm talking about the mathematical method of broadcasting. I'm not talking about that, public thing where you like, or media kind of broadcasting. I'm talking about like broadcasting in matrices. So if you don't know what broadcasting is, so let's say for suppose you have one matrix that's a shape of 0 0 1 2 1 1, and you have another matrix. Okay. Someone someone has joined. You also have another kind of matrix where let's say you have the same number of columns. The column number is same 2 0 0 1 0 1. And if you want to add them, I'm not talking about matrix multiplication, I'm talking about like adding them. Then in matrices, it's not really possible because you cannot literally add these kind of things. But what NumPy or NumPy library does is that whenever it sees shapes like these, wait, sorry, that should be that should be like this that should be like this shape. Wait. Um, where is the marker? Um, Wait, what? The marker suddenly disappeared. I don't know why. I don't know, man. What happened? Let me just again reload. What? Anyways, leave it. Let me just use OneNote. Both are exactly the same. I don't know what happened here. Why the marker is not showing up. It should show up. Forget this. Doesn't matter at all. Okay. So let's create a new one where don't sync. Okay. So basically, broadcasting means that um, broadcasting. What's happening, man? Oh no. Let me just show it here only. I don't know what happened to my whiteboard in NumPy. So basically, that allows arithmetic operations to be performed at arrays of different shapes. That essentially means that, let me just show you once. I That should come like, I don't know what's the issue here in this app. Today my luck is, I guess, very bad. Um, okay, now this pen icon has come. Okay, so now broadcasting, like as I showed here, this is a kind of matrix. Let's say we're suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 3 by 3 matrix, 3 comma 3 matrix, and let me just use a different color for better like understanding. This is a 3 comma 3 matrix, and let's say for suppose I'm taking this one, I guess. That's 1 0 1. So mathematically they cannot be added. if you try to add them, they cannot be added because the shapes don't match. But what NumPy does is, let me just like mark its dimensions, 3 rows and 1 row, so it's 1,3. So what NumPy does is that, yeah, it uses special operation called broadcasting, and by broadcasting, you extend or extentiate this array or matrix into, I'm using a different color, let's use this one only. So what broadcasting does is that like it it tries to match with this shape, and it extentiates like this, and it becomes 101 101 like this. That's the main thing. Let me just teach here only broadcasting. The error doesn't matter. Yes, I know. So okay. I forgot to add the data. Oops. Anyways, forget this for now. Let me create a new file. Hmm. It's gonna take a bit of time. I don't know what's happening. That shouldn't be the case. Anyways, doesn't matter. Let me just place. Okay, it has. So I import NumPy as NP. So we are going to start from scratch again, like building the model. Now what we are going to do is, let's make an array as x is equal to numpy dot array. What should I make? Let's make a matrix where this, and again this, where they are separated by commas. Let's make it 12, 10, or better 1, 2, 3, and then 4, 5, 6, and then again 7, 8, 9. This is your 3 by 3 matrix, and let's say suppose y is equal to numpy dot array 1, 2, 10, 0, 1. So I guess they should be added, x plus y. Oh, see, as you can see, they are added, but see, their dimensions do not match at all. And let me just show you once again. Print what's x dot shape. It's a 3, 3 matrix. And what's y dot shape? It's hopefully wait. Just is my voice audible? Because I think I have some kind of network issues. I hope it doesn't like affect. See, it's a 1, 3 matrix. So what it is doing, it's like, essentially it's basically doing this thing. So if I use broadcasting happens normally, okay. You don't need to like use any kind of function for that. So broadcasting means I'm using like BC only, broadcasting short form. So basically the matrix was like 1, 2, 3, 4, 5, 6, 7, 8, 9. And another matrix was like, just ignore this. Another matrix was like 10, 10, 0, 1. So what NumPy did was that when I added them, it like extentiated this thing, and it again like tried to match the shape of this thing. So it did like this, and it went on. That's one thing you shouldn't forget, by the way. That's a very important thing. Now let's create a data. Let's use something. So let's just ask ChatGPT for a demo data. Um, Create a demo relationship data of that I can use for my linear regression model. And it should have exactly two columns, red rows. Wait, not two columns actually. Okay, let it be like this only. It would be better to visualize. Wait a minute. Does number of columns in dataset mean the number of dimensions? Let me just check. Yeah. So let me just. I guess it has created dataset. Okay, CSV. So I'm giving you all a file or a document. You all have to like paste this thing. So what I'm doing is I'm using a small method. I don't like let me just drop here. Why isn't it happening? So just check this once. This thing. Wait. Okay. So I'm just copying the entire data and I'm giving it here. So what you have to do is, I guess you all know only, you just have to like create a kind of CSV file. Like, let me just name it as data.csv and then like put here these things and then save it up. And then now I can like directly, let me just cut this one. And I also need the pandas library, of course, import import pandas as pd and import matplotlib.py plot as plt. So I will be going very fast, okay? Like, but if you have any kind of doubt, then I will like explain at the exact moment. No need to worry. So first I'm defining the data. Define. And I cannot share the code. Okay, like I have some kind of issues where sharing code is actually difficult because I did not create any kind of repository for making those code. Define the define the load the data set. So I will do is like data is equal to pd dot read underscore csv. Then I will like name that path, of course. Copy path and then here. Oh, I did not do this. Something has happened. Hmm. Oh, I, I like misplaced this thing. I like renamed the wrong folder. Sorry, by the way. Okay. So this should be the data.csv. Now it should work. Now let's check. Yeah, now it's working. Now if we try to like see this thing, let me just view the first 5 column, head 5. As you can see, it's showing the direct linear relationship between this thing and marks. So let me just cut these off. I'm going in the full screen, okay. I hope you can see this. So now what I have to do is now like um, now I want to like visualize the data. So for better like thing, so first of all, plt.figure fig size is equal to, let's say it's of course a tuple 10 comma 10. 10 comma 10 is I guess ideally good only. Plt dot scatter. That means I'm essentially scattering these coordinates. These are nothing but coordinate. Like this is x. This is like you can write this 6.75 comma 63.38 like this. That's essentially the same thing as coordinates. What it is like x. Oh, I forgot to like mention these things. I have to like again mention that like declaring the x. So what I can use is x. X will be of course x is equal to data dot draw. That, and whenever you're declaring x, I can also write it as this thing. I can also write it as a name of the column which is study hours because I'm referring to this thing, right? But when we have like more columns, here only one, there's only one feature column, but when we have more feature column, then we cannot use this. We cannot refer to this thing as a whole. We have to use this thing, data drop, and we have to like drop this thing. Drop the target or the label. So that would be of course marks, and y will of course be, y is only one column. Okay, so we are referring to this column. We want to target data of course marks, and now it's, wait a minute. Oh sorry, I forgot to mention the axis. Is equal to 1 because I'm referring to the column. Now it should be right, yeah. Now I'm scattering these things. I'm scattering x thing and y thing. So it should be like x comma y. So now if I try to show it to you, it's basically like this. I hope you can see. Let me shorten the size. Let's make it 7.6.5 and then 6.5. You can see, right? You can see the data. Sure, Inuvi Rakshit. Sorry for replying late, by the way. I was just like not checking the messages. But you can use any kind of CSV file, whatever you want. It's totally upon you. I hope you are here, Inuvi Rakshit. So this thing, now what we want to do is, we want to like make a kind of straight line which passes through this. We cannot use any kind of direct formula. Like there is a direct formula for two variables. But the thing is that the two variable thing is not usually preferred. The formula, direct formula is not preferred in machine learning. In machine learning, you use a certain function where you pass a wrong output and then you calculate the gradients. Gradients means the derivatives, okay. And then like you update the weights, biases and such. Now, as I said, W will of course be like, let me just make it weights. No, W will also be fine. Is equal to, it should take the exact shape of X. If you are like doing matrix multiplication, then it should take the shape of like the column of X and Y. So, see, X dot shape is 100,1. So, the shape of Y should be like, not y, sorry, w should be around like 1,1 if I'm not wrong. So it would be like np dot once bracket. Let's make it random. Random. Now see, if I try to, it is like this. Now if I try to matrix multiply this array like x at the rate w, it should be possible. See, it's returning a full thing. And it's like, 100 comma 1. It's like dimensions is 100 comma 1. Also, you can see like is also, y is also having a dimension of y dot shape. It's also having a dimension of like, 100 comma. I'm just like, reshape. I guess y can be broadcasted. Wait a minute, let's try w plus y. No, it won't because I have to like make it a kind of, see, the shape of y is like, wait, it's y dot shape. If I try to show its shape, it's something showing like this. But if I try to show w dot shape, it's showing like this. Sorry, x at the rate w dot shape. It's 100 comma 1, but here y dot shape is like 100 comma, so I have to like put a I have to like change its shape so that it has a column. So it's very simple. You don't do anything, you just like do this thing, I suppose, and then it should be done. Yeah, see, it's very simple. Just a pause. Are you all understanding what I'm trying to explain? If anything like comes, like if if you ever find the value of y to be like, not value, essentially like the shape of the y to be like 100 comma empty, then just like enclose another square bracket and it's automatically 100 comma 1. I hope you all got it right. Just type in the chat. And bias will be, of course, numpy dot shape. That should be the shape. I was wrong. It should be x dot shape dot 0. And of course, this would be 1. Numpy dot shape. It takes some. Oh, and we got zeros. Sorry, it should be this thing. Oh, it should be zeros like this. What's happening? I guess I should make it like this. Yeah, like this. So B, if I try to do it like this, it will happen like this. Now, sure. It's meant to be complicated actually. So basically, you understood the loading the dataset thing. Now I have to declare x and y. So basically, for x, I am dropping the target column. That is, I want to find the marks. I want to predict the marks, so I'm dropping it. And x is equal to 1 means that I'm referring to the column which I want to drop. And y equals to like data. And I'm referring especially to the marks column which I want to like target. Now weights are numpy or random. So I'm randomizing the weights in the value of 1 comma 1. But always remember that they should like the the first thing should be exactly equal to the column of the X matrix. Now bias is equal to x dot shape 0, comma 1. That means that you know the first thing of the first it will take the shape of the resultant of the thing. Let me just write a better word that is y dot shape. That would also work. That's not a thing. Now if I try like use the matrix for like x at w plus bias, that would work. See, this is the first prediction. I hope you understood, right? I hope you understood. Now I have two things. Okay, I have two things. What do you want to learn first? Do you want to build the model from scratch? That means building directly from NumPy, or do you want to use scikit-learn? That is a machine learning library. If you do this, you will get the result in only 10 lines of code, and if you do this, you at least need around, let's say, 50 to 60 lines. Both are good, but in production you use this thing, but to understand you use this thing. Which method do you all want to like choose? This or this? Using scratch or using scikit-learn? Not scratch, like making from scratch. Which one do you want to use first? I'll be teaching both. Just type in the chat option 1 or option 2. What about the others? I expect a reply from you all. Oh, okay, looks like you will first want to build it from scratch. Okay, no problem. That's actually a better way to learn first because you understand what is going inside the model. So we already made this thing and processing the data. So this thing is done. Now we have this plotting. Now let me just keep the plot off for now. Here's the output. And let me just put a code block below it. Now what we want to do is define a function. Let's name it as, you know, linear define pass. Oh, define fit. Fitting means, I am fitting the data into thing. I'm fitting the like these things. So I will use x, comma y, comma w, comma b. Return. Now what should I use here? What do you think will be you? What should I use here? Just try to guess. Just try to guess what should I use here? What should I return? What should I try to return? It's of course this formula x at w plus b. Should work. Now I'm also making this is like I'm passing the thing. Uh, now define cost. Let's say y underscore bread is equal to. Okay. return. I have to use y because I'm calculating the thing. So I will use y and like this. I just want y only. So yeah, return bracket. What should I use now? Um, mean squared error. So I'm using this formula. Wait a minute, let me show you. Mean squared error. Its formula is something like this. Don't be scared about this thing. You just like in code it's very simple. You just use this thing. NumPy dot mean and again power 2. That's the entire thing. Now let's say or suppose I just want to try this thing. Let's say fit bracket x y w comma b. I'm using this function. I'm using a lot of I use a lot of object oriented programming. So I like I sometimes forget the main functions like so. No issues by the way. Now I'm understanding. Number is equal to, let's say result is equal to fit. Now essentially fitting these things y w comma b. That means I'm calling the function. That's the main thing. Now if I want to print the result, that's it. This is the result. Now do you think this result and dot concat. Now let's say ed dot concat. Let's say for example okay, so ignore that this thing 0, this is the different thing. So let me just show you that columns. Anyways, I'm renaming the thing. Okay, result of columns mean that means I'm basically like naming the column. So now do you think, see, does this do these things match? Do these values match? Do these things match at all? See how, so that means that I have to make the model learn from this thing to match or like at least like to learn some parameters from the data. So what should I do is, let me just check the error first result dot. And what I will do is I will like now find the cost. Let me just name it as error. Error y comma y pred will be result of course because it's the predicted value. Not a number. Shouldn't be the case. Oh, I forgot to do this thing. Wow, y is equal to numpy dot array y x is equal to I dot array bracket x. Okay, now it should happen. Now you can see what a big error, right? See, this is such a big error. the error is literally like 3.818 point this thing. The reason I've converted them to NumPy errors is because if I don't convert them to NumPy errors, then it will show like what to say. There will be an error in mathematical things, so it's better to like change them into arrays, both so that it works nicely. Now let's go. Now what I have to do is now see. I'm now using a bit of math here. Um, Linear regression cost formula is basically like this, 1 by m, that is mean. This is a total thing, phr. Then you do the summation of these things, and then you use y. This is a square, okay. This is the basic function of mean squared error, or you can also use this thing also, doesn't matter much. Like this is like 1 by m. You can use there are two methods. You can use like, wait a minute. Yeah, it's frequently correct. I is equal to 1. And it's not, sorry, it's I is equal to 1. That means it's starting from 1 and it's m. And it's doing like this. So basically remove the 2 for now. So basically you can also write it as 1 by m and then I is equal to 1. Then wow, the formula of y hat will be of course x at the rate w. At the rate means matrix multiplication, okay. Minus y. Y will be y only. Y predicted is the value which we want to pass. This thing, for example. Y predicted means x at the rate w plus p. Because wait. Now I guess you will understand this thing. Now, yeah, exactly, in reduction. Now you can see y prime is equal to x at the w plus 2 because I'm fitting the data points. So you don't necessarily need y, but I'm just like keeping it as a standard of measuring. So now, as you can see, it's directly written here. Y hat is the same as y prediction. So you can also write this x at w plus minus. Oh, sorry, I forgot to use the plus bias minus y whole square. Now just ignore this thing, okay? No need to use this thing for now. Keep this aside. Ignore this thing. I'm not saying like do this thing, but no. Let's just check one thing. In NP, I guess it's NP of mean. Yeah, exactly. See, now there's a reason why I'm not doing a summation symbol. It's because see, matrix in NumPy, the summation operator works on its own. So you don't necessarily need to use this thing. Especially in arrays, the summation operator works pretty much automatically. So you don't need to use this. Anyways, is my voice clear? Because it's raining much more heavy. Is my voice clear? You all can type in the chat. Okay, now we have to find a partial derivative. So partial derivative, I guess you all know what is partial derivative. Del w by del sorry. I have to use like, del z by del w, and I have to also find del z by del p. Do you all know what is partial derivative? I'm not talking about derivatives, I'm talking about partial derivative. If you don't know, let me explain these topics very quickly. Partial derivative means you are differentiating a multivariable function. Let's say, suppose f of x is equal to y. Y is also equal to f of x. Okay. So which is equal to, let's say, suppose 2x 2a square plus 3b square minus a. So for partial derivative, you like try to differentiate the variable instead. You can differentiate it like, single-handedly in one go. You have to like apply them, apply partial derivative. So the function will be of course del y with respect to first you have to do with respect to del a. So that would be of course, now in partial derivative whatever variable is mentioned in the denominator, you only focus on this thing. You ignore the rest. You ignore the b variable. You only focus on a. So it will be like 4a. It will be like something like minus 1 if I'm not wrong. It's something like this only if I'm not wrong. Let's check it. No, a square. A square. It should be like this. I hope so. I may be wrong also because 4a minus 1. Yeah, 4a minus 1. Yeah, I'm correct. I'm correct. So that's the thing. Now we have to differentiate the thing with respect to biases. Not bias like b. Del y by del b. So it will be like 6b. Now with respect to b, so b is the denominator. So I'm only focusing on b. I'm ignoring the rest for now. That's the main thing. There is also a derivative rule called the chain rule. Chain rule. So let's say you have a kind of thing like 2a a whole square. You can differentiate it by either like using the long method, which is like doing this thing, or not 4, sorry, 4a to the power 4 minus like a to the power 4 minus 4a square 4a cube, sorry, plus a square. And now like apply the derivative thing, which is like 16a cube minus 12a square plus 2a or you apply the chain rule, which says that you first break the power. That means you first do this thing. You first differentiate the whole like exponential function or that thing. So that is like 2a square it's something like this only. If I try to differentiate it, then it will be like this, and I will again do it like, uh, now I will now, this is the thing which I obtained by breaking this entire thing. Now I have to break what's inside the bracket, and it's like, 2a squared, that would be of course like, 4a and negative a will be of course like minus 1. So it will be around like, oh, 좋아. 모르겠으면 뭐였어? 좋아. 몰라서. And now like 4a minus 1. Okay. So now you will like 4a squared minus 4 squared minus 2a, and then you factorize 4a minus 1, and then you apply the rest thing like, and then you see I have done here the main thing like this, and this is the chain rule which I am trying to show. Now the result will be like around 4a 16a cubed minus 4a squared minus 8a squared minus, I'm multiplying them, okay, it's like, I'm multiplying. It will be like plus 2a. Now again, it's like this is equal to, what will be equal to 16a cubed minus 4 is minus, 12a squared plus 2a. This is the long method, and this is the chain rule. Chain rule is very effective when you are dealing with long powers, like very large powers. See, here I have like broken the function, like broken this thing into like its code square identity, and here I use the chain rule where I, like, first of all, if it is in the form of a squared minus, like let's say for the purpose, if it's in the form of ax to the power n plus bx to the power m to the power z, then first of all you will differentiate the power thing, which will be z a x n plus b x m z minus 1. You first do it like this, and then you do it, and then you multiply it by the breaking the inner derivative. Okay, n a x n minus 1 plus m b x m minus 1. I hope you all are like, I hope you understood chain rule. Chain rule basically means that I'm breaking the derivative by its power. I hope you understood. Anyways, is my explanation like correct, like of the chain rule? Because I'm currently in 10th grade, and that might sound, I may not be the best at explaining the chain rule, but is it like correct? Because the answers are correct, but am I like teaching in the correct way? Okay, thanks. And partial derivative means you are ignoring the other variable and focusing on the variable that's in the denominator. So now, that's the main thing. Now you might be thinking like, why am I teaching this thing right now so suddenly? Like, why did I jump from code to this? So the answer lies in the main thing is that you differentiate the error function. That means I'm differentiating this function and to find the weights. So what I have to find is that the weights and values. So what I do is, let's the cost function, let's name it as z. Z is equal to, of course, this thing entire. So 1 by n. Ignore the summation sign. Okay, just ignore it. It's not needed, especially in NumPy. y hat minus y whole square. So z can be also written as 1 by m y sorry x at w plus b minus y whole square. Now what I have to do is I have to find the what things do I have to differentiate, like del z, of course, del with what, and I also like to find another thing. Let's name it as, and I also need to find del z to del with what these two can be. Just try to guess what the denominator variables can be by this function. Just try to guess which one should be. Which one should I differentiate? Which two variables should I differentiate? The answer was right. What I said. No, Aditi. Aditi, you are like very close to the answer. Like, just like change another one. I'm giving you a hint. Okay, you have to differentiate the functions which change the output. Here m does not change the output. Here y also does not change the output of the main thing. What influences this is w and bias. And in Linear Regression, uh, you will get, yeah, exactly. See, y never influences output. X is always remains the same. You cannot change it by law. And m does not really matter. So the weights and biases, you literally you tune them to train a model. Inuguri Rakshit, yeah, you are correct. I guess, Inuguri Rakshit, you will get a nice answer, by the way. A pizza has been given to you. Let's go. So what I have to do is, now I have to now let us remove this thing. So that would be del z with respect to weight and del z with respect to bias, sorry. Bias. I hope you all got it. Now let's differentiate this thing. Let's differentiate this thing first. So let me just bring it here. So let me just bring it here. So no, let me bring it here on loop here. So weight. So if I'm thinking of the weight, so that should be always that should be always So I'm basically differentiating this thing. I'm basically x at rate w plus b minus y whole square. Now I have to ignore these things because I'm referring specifically to this thing. So that would be, now I'm applying the chain rule. So ignore this thing, ignore this thing. You can also ask Google also, when differentiating of what of so when this in bracket. I may be wrong also, who knows? No, you don't do this. Yeah, Aditi, you are correct, you are correct. You are exactly correct. You're exactly correct. You're exactly correct. Like I don't essentially ignore them like in a strict sense, but like I try to do this. Let me apply the chain rule once. So first I will differentiate the power. It is 2x. Okay. And then again differentiate this thing. Because I apply the chain rule. Now again I try to differentiate this thing. So that should be like uh, I will be ignoring this thing because it's a partial derivative. I will be ignoring this thing. Yeah, exactly. Now I have to ignore this thing because I'm breaking the inside derivative. I'm not breaking the power thing. Now I'm breaking the inside derivative. I have to ignore this thing and this thing. So now what you will have to do is you will try to differentiate this thing. So when I'm differentiating with respect to w, so w will of course become 1 because w power is 1 and 1 minus 1 is equal to 0. and, and anything to the power of 0 is always 1. So it will be, and we have x. X won't be ignored because it's a coefficient of w. And anything that is like coefficient of the variable which we are like the differentiating with respect to, that coefficient is not like ignored. It's always there. So it will be x. So it should be like 2x x at w plus b minus y. You can also shorten this to like 2x y hat minus y. That also works. Now what I want to do is I want to now differentiate the with respect to this, with respect to bias. So what I have to do is let me just go here. This is the differentiated thing. Now what I have to do is like I have to differentiate this thing bias. So what I will do is applying the chain rule. I will apply the chain rule. It will be the same as like this. So it will be like it will be the same as this thing, but this thing will be different. 2 bracket x at w plus b minus y multiplied by again you're differentiating the bias. So one thing you can see is that there is like you ignore this thing also, you ignore this thing also. Since bias is the coefficient of 1 and it has a power of like 1, so it will be 1 only because on differentiating b we get as 1. So that would be like 2 x at rate a w plus b minus y. You can also check this. So now we have calculated like the derivatives. I can also ask Google also this thing, right? See, del cost, del z, you can also write it del z, whatever, that doesn't matter. With respect to the which is 2 wx plus b minus y with respect to x. And what is here? 2, wait, 2 x at rate w plus b minus y multiplied by x. That is like 2x, then x at rate w plus b minus y. That is, I'm shortening it like 2x y hat minus y. That's also the same thing. It's correct. Let me just use another marker. It's correct. Also, let's view this thing. Del cost with respect to del bias. That's 2 multiplied 1 of course, and my also is correct. So basically that's the entire thing. I hope you understood the thing. Right. I hope understood. And like whenever you are differentiating any kind of thing, just try to like if there are any kind of power inside a bracket, like out, if any kind of function is there where it is enclosed within a bracket and has power, then always apply the chain rule. And if there are like many variables but you have like differentiated the power especially, then always apply the partial derivative thing. You can also write it as like, 2 at rate x, you can also write it as 2 at rate x at rate, oh sorry, 2 y at minus y. That's also the same thing. I can also ask Google this thing like, so here's the BIOS, so when created with 2x y at that's the exact same thing. See, that's exactly correct. So now you can use this thing simply and that will work. Now here we have to apply sum. Now what you have now what you do is now next define gradients. Not gradient, the where for descent. So d underscore w means I am differentiating the differentiated w. Okay, that would be like let's say those. Let's say, let me just make it more simple. How can I make it like? Um, uh, how can I make them more simple? Return, and then, okay, let me just put it here only, okay. Now, let's say, n is equal to len, bracket x, bracket with x, and then, differential w will be, of course, like, pi dot sum, by n, multiplied by pi dot sum, bracket, 2, divided by x, opposite, multiplied by the that is the same thing, and derivative of bias will be like 1 by n divided by n feet of sun versus 2 multiplied by this is the differentiated thing, and I can even prove it to Google also that it's correct. See, it's exactly correct. That's why I have not used the, you can see that's why I have like shortened this thing. See, I can also write an x at w plus b, but that would look very weird, so I will use this thing. Like, why, like, it's always good to use shortcut. Now, return, I also return like, let's go, yeah. Now what you do is, define gradient Well, I'll just keep it here only. That's the entire thing. Now we have to calculate the gradient descent. So what we can do is like, let's now write the thing x y underscore pred is equal to, of course, pit bracket x comma y comma w comma b. Since I already have them, so it's like this. So I can show you the thing. Underscore pred. Let me just ask you a question to you all. Like, are you all understanding what I'm like trying to teach? So basically, I have like passed a function here. Just like type in the comments. Basically, I'm like, I have like first like to make things, is my explanation clear? Now, what you do is simply just do the error. Now, let's say since there are three variables which were returning, like this thing, and this thing, so we can like name it as error, not error, loss amount. Because if I write error, then sure. Let me just finish this first. I'm basically putting the values of here. Uh, okay, okay, sure. No issues. Now let's make a loop. Okay, now we have to make a training loop. Training loop. Let's configure our learning rate. Let's make it somewhere around 0.01, 0.1, and epoch. So now what we'll make is we'll first now do this thing and calculate the gradients. Now what we will do is for epochs, just try to remember that in epoch and epochs are different things. In Uber actually I will be like explaining this soon, like just try to go along with me. Let's go. Now this thing is done. Now we can like train the model. This is the learning loop. Okay, this is the learning loop. Let us make it learning loop. Now what you do is now the thing is done. You have successfully made your first machine learning model. This might make some errors, but let's check once. So now let me just explain. So now what you have essentially done is that, see, can you see the model is learning? Let me just run it all over again. You can keep it to whatever you want. Basically, they are the same thing. Now see, the model is learning. Because see, in this loop, this thing was this. In this loop, it was like this. This loop, it was like this. It goes on and on and on like this. I guess it should be around like LR should be around 0.01. Now basically this is the machine learning model. So basically what I have done is in Redshift, I first load the data set, that's obvious to you, and then then declared and processed the data. That means I've dropped this thing, and I've like now converted now I've converted X and Y into numerical Python arrays or NumPy arrays so that they can be used for mathematical functions. And then I made the weight as a random kind of thing that is 1, 1, and biases as like zeros dot y dot shape. That also works. And I've made the fit thing which I like. Now I've made a formula to pass the thing. Okay, I've used the means like weighted sum function to matrix multiply and use the slope intercept formula to like give a wrong output at the first attempt, and then at the error, and then the error needs a kind of like calculation, right? So I've made a function which calculates the error, and I've used these things to like these variables to be specific, and this is the length of x, of course. And now I've differentiated w weights and biases, which I've shown you in the whiteboard, I guess so. And I've like then like tried to do this. Now I've returned these things. Now this thing, and yeah, that's the main thing. Now I've like tried to like now I'm calling the function. Okay, so this thing will take the values of whatever this function returns, and this thing. And now you might be thinking like why there are three things like loss, dw, and dv. So when I'm returning three separate variables, then I will use three separate variables here also with all the function. Now I've made a learning loop where the model essentially learns from the error. So I've used learning rate as 0.001. You can use anything. I've made the epoch as this thing. Both are essentially correct. Okay, that's totally up to you. I'm just using a smaller thing. Now you can see I made learning rate so that the model learns in a particular rate, and I made an epoch. And now for epoch in range, so I made a loop where the model continuously updates its weights. So for example, see, the values can be overwritten. Okay, so one weight is equal to this thing. The first loop, the weight is like around this thing. The second loop, the weight is this thing. And the third loop, it is like this. Wait, it's epoch plus 1. Okay, go. Sure. At epoch plus epoch 1, it's like this thing. At epoch 2, it's like this. It's 3, 4, 5. And it changes till it reaches the local medium where it makes the less error. Got it? I can use this also. That's totally fine. That's totally up to you. Okay, that doesn't matter. That like matters a lot, by the way. But that's totally up to you. And I can set this up like this also. My PC is gonna crash if I give so many long numbers, up to like 100. Or somewhere around like this. Or I can use like 0.1 comma 100. That's also same. You cannot say that actually. The model makes the correct predictions only at any random epoch or learning rate. That's totally up to the model on how it learns. I've basically shown the main loop that is like this. This thing. Now let me just try one thing with one is to prediction. These are new weights. Okay. Now let's check. Just clear this off. Okay. Now what I'm going to do is go here. Please cut this off. Uh, let's try to visualize here. Okay. So what I will do is like DLT dot log. Oh no, that wasn't expected. Yeah, see, that wasn't expected, that was very big. So I have to like again change it like 0.01 like this. Now again the model will learn like this. See, can you see it's like changing? It's repeatedly changing. So it's up to you, like now again I have to like make it much more smaller like this. Oh, that became too much small, I guess. Now see, are you seeing the machine is learning? Can you see the machine is learning? That's the best in machine learning. So whatever like these are data I calculated, but these things totally depend upon you. You have to set this up, okay? And now you might be thinking, why am I passing this thing again? So this is a new prediction, okay? That is x at the rate w plus p. Now it does not see this w or v. It checks the differentiated w, that is this and this. Now if I again like try to move it a bit more like 0, 0, 1, that should like um, no, that's too less. 0, 0, 1. Okay, great. I'm like really close to the output. No, no. Okay. Yeah, now can you see the model has finally learned the actual thing. Can you all see the model has learned from the data finally? So basically, this learning loop is the most confusing thing because you have to like manage it so correctly. Like the if you like change these values a bit, then the model might make the correct error or the wrong error. Now I can also check like what's the value of y underscore pred. Let me just check. Now let me just check the accuracy. Okay, don't leave the meeting. Now let me just check the accuracy. Let's check checking the accuracy. Accuracy. Now let's go like accuracy formula is basically like y pred minus this thing. Y minus y pred. So I can like y underscore pred. See, this is almost like matching. And if I try to like let's say y pred, let's say pd dot concat bracket y pred dot pred now y. I don't know why it's happening. Oh, shit. Right. Oh, that's simple. Y underscore pred is equal to. Now to check and visualize the data, you have to again convert this thing to like, y pred pd.df data. 어. 봐. 술 새끼야. 나영아. 시원하구나. 어? 이따 로이스 just. 아, 얼마나 잘. 아, 춥다 하나, 좋아나. मातिए रहेगा चुप থাকা मातिए रहेगा okay let's go मातिए থাকিবা না চুপ থাকা লো now like a neighbor was calling me right now I don't know why let's go anyways forget this um, so you have to like now make it into a data frame right? Same for this thing যোৱা না পদক্ষেপ যোৱা না মাতি আমাকে কৰাই আছো মই চিঞৰ থাকিবা যাম মই যাম চিঞৰ থাকিবা যোৱা এতিয়া ইমান টাইম আছে এনে এনে চিঞৰি আছা এনে কামুৰি থাকা তুমি so you can see this is the যোৱা নাই মোৰ পৰা now you can see this is the see how close are these outputs right you can see this 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 they are like very close so that's how our machine learning model learned so basically if you have went through that code you have basically built your first machine learning model and congrats for unlocking this thing now you can like try to play with it like yeah what accuracy is equal to y is to pred minus y print accuracy that depends if you like that depends upon the model and the data you cannot like it can either change or it can either give the wrong output or it can give the correct output you cannot predict it see and if I like try to like find the mean of it like and mean not mean if I try to find the average error that's almost like 2 so that means our model has actually learned from the data and it has like making like very less error it is making like less error than its so accuracy so I can also like print it's like accuracy by accuracy so that's a 99% accuracy so what problem do you think there is in the model what problem do you think it's in the model it's making the correct accuracy but what problem do you think the model is making just try to guess the model is giving correct output but there's some real life issue with the model like the model isn't wrong but it has a very serious issue no not at all it's I'm just teaching you as an extra scattered data does not matter linear regression like finds the best line of fit it's the model is overfitting see if the accuracy is this much it is overfitting overfitting basically means that overfitting that means that the model learns the training data so well that it memorizes its exact details and noise so that means the model is fitting the data so perfectly that it's like it's fitting very perfectly so it's overfitting so it's basically memorizing the data so if its accuracy is like 99 or something it basically yes exactly exactly and I'm like and this model isn't wrong by the way but it's overfitting so basically समझो कि मतलब एग्जाम में दो तरह की मतलब स्कूल क्लासरूम में दो तरह के टॉपर होते हैं ठीक है मतलब एक होता है कि जो सिर्फ रट्टा मार के जाता है और एक होता है जो कॉन्सेप्ट्स को अंडरस्टैंड करता है और मतलब अच्छे से अप्लाई करना चाहता है सो जो इंसान रट्टा मारता है ना वो एग्जाम में अच्छे से करेगा पूरा अच्छे से करेगा लेकिन जब मतलब उसको एक नया वाला सिनेरियो में मतलब if you like tell him to apply to a new world scenario or real life scenario, तब उसको मतलब थोड़ा मुश्किल आएगा, नहीं तो मतलब उसको थोड़ा प्रॉब्लम्स होगा. लेकिन अगर तुम और एक टॉपर जो मतलब कॉन्सेप्ट को अंडरस्टैंड करता है, अगर इसको कुछ चीज़ देते हो ना, तब वो रट्टा तो नहीं मारता है ना, अच्छे से अंडरस्टैंड करता है. इसके बाद मतलब रियल वर्ल्ड केसेस में भी वो मतलब अच्छे से परफॉर्म कर सकता है. ये मेन चीज़ है ओवरफिटिंग का चीज़ में. बेसिकली मतलब ओवरफिटिंग मीन्स रट्टा मत मारो, डेटा को अच्छे से सीखो. एंड द मेन now what is the main reason why there is overfitting? Can you all like try to understand, like say the answer is right here. I have not used one thing. I have not used one thing, and that's why the training data is too much used. What can it be? Just try to like give an answer. Just try to give an answer, even if it's wrong. Well, the answer is that I did not use the train test split. Train test split. That means I did not split the training data and testing data into parts. So that's what you will be learning today, and today's session is officially over. It was a long session, by the way. How was the